Last, we need to talk about oblique asymptotes. And oblique asymptotes only occur when there is no horizontal asymptote. So when there's no horizontal asymptote, that means there will be an oblique asymptote, at least for the examples that we do. So right here you see the formal definition of an oblique asymptote, but basically, if we zoom in on this graph, if the numerator has a degree that is one more than the denominator, so the degree of the numerator, again, is one more than the degree of the denominator, then you are going to have an oblique asymptote. Okay, you might want to pause this to copy this down. I'm going to scroll down to the next example. So for the first example, we have y is equal to 3x cubed plus 2 divided by x squared minus x minus 7. So you can clearly see that the exponent of the numerator is 3, the exponent of the denominator is 2. When this happens, you set up a long division or synthetic division, but most of the time it has to be long division because of the functions that you're working with. You set up a long division problem. Whatever's in the numerator is going to go under your long division sign. Make sure you include all terms. So our numerator is 3x cubed. We have plus 0x squared plus 0x plus 2. That's our numerator. Our denominator becomes our divisor. That goes outside of your long division sign. And then you divide out the function. So we have our first term, 3x cubed divided by x squared, just like previous long division problems that we've done. When we do this, we're left with 3x. That's our first term. 3x times all terms, we have 3x times x squared, which is 3x squared, no, 3x cubed. 3x times negative x is negative 3x squared, and 3x times negative 7 is negative 21x. We are subtracting all terms. 3x cubed minus 3x cubed is 0. 0 minus negative 3 is positive 3x squared. And 0 minus negative 21 is positive 21x. Bring down the 2. Repeat the process. 3x squared divided by x squared is 3 for your final term of your quotient, of which you multiply out to all terms in the divisor. This gives you 3 times x squared, or 3x squared. 3 times negative x, negative 3x, minus 21. We're subtracting both terms. Sorry, we're subtracting all three terms. 21 minus negative 3 is the same as adding, so that would be plus 24x. 2 minus negative 21 is the same thing as adding. 2 plus 21 is 23. All right, so when you are finding the oblique asymptote, your oblique asymptote is only the quotient. So I'm going to label this as the remainder. But we actually don't need it. So previously we've used this. Now we are only looking at the quotient. Oops. So if we were to label our oblique asymptote, first of all, anytime you have an oblique asymptote, you instantly have no horizontal asymptote. So I'm going to include that in this answer. No horizontal asymptote. And then oblique asymptote, we're going to write it as a function. It's always in slope-intercept form. It's this function, it's your quotient. Forget about the remainder. The remainder is not part of your answer. So y is equal to 3x plus 3. This is your answer. That's it. Just the quotient. Of course, we have a remainder. We do not want to use it as part of our answer. Okay, for number 2, same thing. Let's compare our exponents. We have 2x cubed divided by x squared plus x minus 12. So I'm going to get started with this one, and then you can just watch me finish the rest of it. But whatever your numerator is, it goes underneath your division symbol. We have 2x cubed plus 0x squared plus 0x plus 0. And our divisor is x squared plus x minus 12. Okay, so if you just follow along, you can watch me do the rest of this problem.